rod will act. The weight of the rod will act through this. So shall we put weight of the rod? Where the buoyant force, you are going to show it. So this is a problem very important. The buoyant force, you have to show it here, the midpoint. Because you see like half of the length of the rod is immersed. Then where the buoyant force will act through center of mass or will act through point D or this particular thing. No, it will act at the midpoint of this one. Along with this, I'll put one, I'll suspend some weight here. Some mass of the particle, MP, I'll write it as. Half of the length of rod is immersed in at equilibrium, find the tension on the string. A heavy particle of mass MP is glued at lower end. Now, what are the other things? The weight of this MPG will act. So these are all forces that are acting. Here only let me write. Under action of this, it is in equilibrium. How the tension the string will act? It like this. So what are the forces that will be acting? T plus FB is equal to WS plus MPG. Okay, now the tension. What is the buoyant force? Density of water. Half of the length of the rod is SB, the area of cross section, is equal to weight of the rod. What is the weight of the rod? Sigma SLG, and this is MPG. So what is the expression for this? This will be sigma minus rho W by 2 SLG plus MP into G. I'll get the tension with the help of this. Now, if I don't give mass of the particle, tell me what you are going to do in that case. So I'll ask you at equilibrium, find the tension, the string, and mass of particle. I think this equation will be of no use. No, you can see like simplest ideas, nothing big. This equation will be of no use for us. Okay, equation 1, okay, fine. But we don't know mass of particle as well as this. Remaining all quantities are known. So this is equation 1, will keep it. Both are unknown. What are unknown things? I need one more equation. Tell me what is the one more equation available. Let's go for torque. So torque, it's in equilibrium. Can we define torque about any point? Yes, we can define torque about any point. Let me go for torque about the point D. Please try to follow things. This is a torque. At equilibrium. So what are the torques will be? Torque due to buoyant force. How it will be? Anti-clockwise. Torque due to weight. Clockwise. Torque due to tension will be anti-clockwise. All set equal to 0. Torque due to buoyant force. FB into L by 4 cos theta. Torque due to weight. WS L by 2 cos theta. Anti-clockwise, I'll take negative. Torque due to tension. T into L cos theta. We don't know theta. That will get eliminated, you can see here. So we'll get equation FB. L also get eliminated. FB by 4 minus WS by 2 plus T equal to 0. What is the buoyant force? Again, once again, density of water. S L by 2 G by 4. Weight of the rod. Sigma S L G by 2 plus T equal to 0. How many unknowns are there? So I know the tension, no? So directly I got the tension. Let's see that. I'll get the tension. So what is the tension is equal to? Rho W by 4 minus sigma SLG by 2. this value of tension as substitute, I'll come to know what is the mass of particle. Get so this is about the equilibrium. Means this buoyant force, can it set up a torque? See, we already know what is that tension can set up a torque. The weight can set up a torque. Now I am bringing the buoyant force. And why you have to show buoyant force? Because this is the volume immersed. Because everything, this is a liquid. This everything is a liquid, no? Yeah. So where the buoyant force will act? Through the center of buoyancy. Okay, let's analyze. What is C? What is C? Center of gravity. What is C? Center of gravity. What is B? Center of buoyancy. We will give a name, center of buoyancy. So through what point the buoyant force will act? Through the center of buoyancy. That is the main idea of this particular numerical. Why I am bringing this numerical is to show that buoyant force not will always act through center of gravity. So what is B now? We should call center of buoyancy. What is C? Center of gravity. Okay, fine. So these are some numericals are there in books. What will happen? You should work out now numericals